Find the volume of the solid that lies between planes perpendicular to the x-axis at x equals pi over 4 and x equals 5 pi over 4. The cross sections between these planes are circular disks whose diameters run from the curve y equals twice cosine x to the curve y equals twice sine x. So the first thing we must do is get a good drawing of the graph. The first one, let's take y equals twice the sine of x. Multiplying sine x by 2 just affects the amplitude. It goes up to 2 instead of up to 1. It goes down to negative 2 instead of down to negative 1. And so just draw yourself a sine curve and just label the max as 2 and the min as negative 2. And if you already have that, then drawing twice cosine x won't be bad either. You could either, do it from scratch, or you could take the graph that you have and shift it pi over 2 units to the left. And so we have this maximum of 2 and the minimum of negative 2. Now, there's planes here at x equals pi over 4 and x equals 5 pi over 4. I mean, these things, they intersect infinitely many times. And so to nail down exactly what region we want, we have x equals pi over 4. We have to find out, well, where would that be in this graph? What is twice the sine of pi over 4? Pi over 4 is 45 degrees, and the sine of that is root 2 over 2. And if you double that, you'll get root 2. But then twice the cosine of pi over 4 would be the same thing. Sine and cosine of pi over 4 are the same. And so this is where the curves intersect at when x is pi over 4. Well, no different from 5 pi over 4. They'll also intersect there. 5 pi over 4 is in the third quadrant. We have pi over 4, and then over in the second quadrant is 3 pi over 4. The 90 degrees is pi over 2 is 2 pi over 4. And then down here in the third quadrant we have 5 pi over 4. And in that quadrant, the sine and cosine are both negative root 2 over 2. So that's the second place that they intersect at when x is 5 pi over 4. Okay, we have the drawing. Just picture that there's some planes here that are basically focusing us in between these two. And the cross section between these planes, so we have, this isn't a volume of revolution, this is a cross section problem. And we have cross sections that are circles. Let me do an attempt at drawing a circle here that comes and has as its diameter, picture that coming out of the screen. The diameter of the circle is the diameter runs from the one curve to the other curve. So it's not a revolution, although it is circular in nature. We have these circles that come out of the screen, running from one curve to the other. Okay, good. We have a good drawing of the graph. The next step in the process when you're doing cross sections is to get the area of a cross section, the formula for it. Okay. So let's go back to what it said. It said the cross sections are circular disks whose diameters run from the one curve to the other. So if you want to find the area of a circular disk, it's pi r squared. Here's the drawing again. And the diameters run from the one curve to the other. Don't get that confused with the radius. Okay, that's a diameter. The difference between those two curves. Twice sine x, the upper curve, minus twice cosine x, the lower curve. That's a diameter. Conveniently, we could factor out a 2. And we already know that the diameter is twice the radius. So right here we have the radius. Sine minus cosine. The sine of x minus the cosine of x is the radius. And that's what's going to go in the formula for the area of this cross section, the area of the circular disks. We need to square it though, pi r squared. So we need to multiply this out. Let's take sine x minus cosine x and FOIL it out. We'll get sine squared. We'll get 2 of these sine cosines, negative 2 of those. And then we'll get a cosine squared. Sine squared minus twice cosine x sine x plus the cosine squared of x. Something should jump out at you. And it's the fact that we have a sine squared and a cosine squared. Let's put them next to each other. We can rearrange them. Why do we care about that? Because the trig identity says that that's 1. So we have 1 minus twice the sine x times the cosine x. Well, there's another trig identity. Hopefully, you know it. Twice the sine x times the cosine x is the sine of twice x. We'll have an easier time dealing with that than the alternative. And so let's go ahead and put that in place of that. So we have the formula for the area of a cross section. You give me an x, I plug into this formula, and it'll spit out the area of that circular disc that shoots out of the screen. So the last step in the process is to perform the calculation. When you're doing the volume by cross sections, the way you find the volume is to integrate from some starting point A to some ending point B, that cross-sectional area formula. Back to the graph, our starting point, of course, is going to be pi over 4, and our ending point is going to be 5 pi over 4. We have the formula from the previous slide, pi times the quantity of 1 minus the sine of twice x. And now we have to find the antiderivative of this and evaluate it at 5 pi over 4 and at pi over 4 and subtract. So, of course, the antiderivative of 1 is x. And we need to figure out what the antiderivative of the sine of twice x is. Whenever you integrate the sine of kx, the antiderivative of that would be the cosine of kx, but you would have a negative that would come in, and then you'd also have a 1 over k factor. Take the derivative of this guy, and you'll end up with the sine of kx. The chain rule will be undone, the negative and the negative will cancel out, and so that's what we employ here. Now there is a negative already, and so the antiderivative of negative sine of twice x would be positive 1/2 the cosine of twice x. We found the antiderivative here, and the negatives would cancel out to give you a plus. If you don't understand, just double check it by taking the derivative of this guy and making sure that you get negative the sine of twice x. Alright, so we just now plug in 5 pi over 4, and we plug in pi over 4, replacing the x. If you double 5 pi over 4, just think about this 2 turning the 4 into a 2. If you double pi over 4, that'll happen again. So you're talking about the cosine of 5 pi over 2 and the cosine of pi over 2. These guys have a cosine of 0. Oh, I lost my half factor. Sorry about that. Yeah, these guys have a cosine of 0. So, 90 degrees, and then 5 pi over 2 is the same. It's it's 2 pi added to that. So that's also 90 degrees. That's also pi over 2, and those guys have a cosine of 0. So those guys zero out, and you're looking at then 5 pi over 4 take away pi over 4. And that's more commonly known as pi. But don't forget the pi that was on the outside. Why was that pi on the outside? Not because of the cross-sectional formula. It's because of this this area formula inside. Not because of volume of cross-section formula. It's because in this area formula we got a of x to be pi times the quantity of 1 minus the sine of twice x. And so that's where the pi came in. And now we have another pi from integration. So the answer is pi squared.